So we have a Hatco pre-warmer for a dishwasher. Hot water comes in, goes through a pressure reducing valve. This pressure reducing valve was actually bad, so we just replaced that. It's only supposed to let 20 psi in. Goes through the pressure reducing valve and then into the heater there. Comes out of the heater up there and then goes up to the dishwasher. Here's a little diagram showing how that's kind of laid out. And you can see right here that it's supposed to reduce it down to 20 psi coming in. And the pressure reducing valve was plugged up with junk, so it wasn't reducing the pressure properly. And then the unit was also overheating, so the relief valve right there was blowing water down onto the floor, right here to this floor drain. We replaced the relief valve because it had opened enough that it wasn't reseating properly. And I'll show you just a screw here, here, and the top one, and then this whole cover comes off of here. Just set that aside. And we got to pull out these 2 1/4-inch screws. That allows us to tip this out. And you'll want to just have it unplugged while you're poking around in here, but this is the thermostat that is responsible for snapping the contactor in and out. These things can be set, I think, between 140 and 160 degrees, depending on how hot the water needs to be going into the dishwasher. In this case, we only need it to be 120 degrees because they're using detergents. If you're using the hot water to actually sterilize everything, then this would have to be set a good bit warmer. So incoming voltage, I did test everything. It was working fine, heating fine, but since this was not opening properly, it was overheating the water, and that would boost the pressure up really high, and then it would spit a bunch of steam and water out the drain right here. So we'll get this opened up and I'll show you what that actually looks like. So I just got something wedged in here so we can properly drain the water out of this thing. Dish screw is in there, so it's not very easy to film. But if you look at this, there's actually a brass ferrule sealing ring. So this will thread into the body of the water heater, and then this plug will follow up, and you tighten that down, and that squishes those 2 angled surfaces together and seals it up just like a water line fitting. Then this will be sitting in the water, taking a nice accurate temperature reading, and we'll just have to put the 2 Phillips screws back into the face of this, and the wires are hooked up here and here. They've got normally closed, common, and a normally open terminal on here, but we're not going to use the normally open. We're going to use the common and the normally closed terminals. So, and then after we get this in here, we're going to just adjust it so that it shuts off and turns on at the correct temperature, and then it should be good to go. On this, we will use some thread tape and pipe dope, but on this one here, this is a compression seal, so we don't have to use anything there. I'm going to have to use a socket to remove the old one, so I'll probably just cut the wire off because it's really tight. I just can't quite get it with my wrench, and then I'll just use a crescent wrench to retighten this back in. So it was the 11/16 socket, and I just used that and an adapter to reach in there. Of course, after snipping the wire off so I could actually get around the nut. Where is it? Oh, right here. So there's the old probe and how it was threaded in there. And I've got thread tape and pipe dope on there. We're just going to spin that in. Then we'll mount this up and connect this wire on the top, this wire on the bottom. When we get water out of there, then we'll close this back off up here. Just make sure it's not leaking anywhere. Of course, I tightened up the end one as well. And then as far as depth goes, you just pull the probe so that it's not very far in, and that's where you tighten up the ferrule. Power switch turned on. We're just going to turn this up until we hear the contactor snap in. So turning it to the right slowly. Okay, there, it just kicked in the contactor. And then we will cycle the dishwasher here. And while this runs, it'll pull water, and we can watch it and see what temperature water we're putting out and make sure that this shuts the thermostat off at the proper temperature. So a little bit finicky, but have to kind of work with it and get it set exactly right. So you can see we're reaching up to our 120 degree minimum. Looks good on there, and our pressure is not spiking like it was before. Hanging around, well, it'll go back up to 20 here in a moment when it shuts off the valve. So we're even exceeding it a little bit, so we can probably turn it down. It is actually off right now, so that's good. So looks like we're gonna be happy. Pulls about 21 amps per element. It's pretty good. A lot of amperage. And then, of course, if you check your voltage, you're gonna have 208 on these. They're just kicked out. So that's good. It is operating as it should. That's getting us to our 120 on the rinse cycle, which is what they want down here. So we have to exceed it a little bit because of the heat loss down to here. So here's where they talk about the thermostat adjustment. Oh yeah, 1/6 turn of the outer screw equals 12 degrees. Recalibration is necessary with the outer screw at high. Stop. Turn the inner screw clockwise to raise the set point. And there's the different temperature ranges it can operate at, between 140 and 150, or between 185 and 190.